कैसे हो सभी लोग? आई होप सारे अच्छे होंगे. So today I'm back with the paper 2 of JEE Advanced 2023 with a video solution on the single choice type paper, single choice types of questions and the numerical type questions. Okay. So in today's video solution, I will be taking up some questions of the numerical type and all the 4 questions which came up in the single choice types question. Okay. So this will be the part 1 of the video solution on the paper 2. Okay. And the remaining video lectures, I will be taking up the rest of the parts. All right. So let's get started with today's video solution. Okay. So on the screen we have the first question. The question is basically a simple question which is on the integral equation. Okay. So as you can see from this question, so let me try it and write the solution. Okay. So let us read the question. Okay. So if you read this question, this question says that there is a function which is small f is defined such that the domain is 1 to infinity where 1 is included and it goes to codomain and real number is a differentiable function such that f at x is equal to 1 is equal to 1 by 3. Now this is a value which is given for calculating the value of the constant, and an integral equation is given in such fashion, this fashion. Okay. And e denotes the base of the natural logarithm, and then we have to find the value of f such that the x value is equal to e. Okay, now let us try out how we can solve this particular question. So if we write the given integral equation, okay, given equation that are given in this question is basically 3 times of integral 1 to x, okay, integral 1 to x ft dt, okay, is equal to x into f of x minus x cube by 3. So that is basically the integral equation that is given in the question where x belongs to 1 to infinity. Okay, so this is basically a domain of x. So okay, so how will we basically approach this particular question? Now from this particular integral equation, now since this integral is unknown in the limits of the integral is unknown, so what we basically think of is by application of Newton-Leibniz theorem. By application of Newton-Leibniz theorem. Okay. So what does Newton-Leibniz theorem says that whenever we have an integral with variable limits, now how we basically do the differentiation of such an integral with variable limits? That's basically the statement of Newton-Leibniz theorem. So if we try to differentiate this particular expression, what we get is basically 3 times of f of x into the differentiation of x is 1 minus f of 1 into differentiation of 1 is 0 is equal to x into f of x, that will be differentiated by using the product rule, that is f dash of x into x plus f of x minus x square. Okay, so this is basically the differentiation of this particular integral equation. Okay, so from here you basically get to the result as 3 times of f of x is equal to x into f dash of x plus of f of x minus x square. So if you take this f of x on this particular side, this become 2 times of f of x is equal to x into f dash of x minus x square. So this is something which looks very similar to a linear differential equation. So if we try to write this differential equation, we'll get dy by dx, okay, into x minus x square is equal to 2 times of y. Okay, so what we did from here, we assume f of x is equal to y. Okay, so from here this differential equation, if you try to make it of the linear differential form, that is dy by dx minus of 2y by x is equal to x square by x, that means x over here. Okay, that becomes x over here. So this is basically the simple format of linear differential equation. Okay, the first order linear differential equation of first order. So this is a linear differential equation of order 1. Okay, so how we solve this linear differential equation of order 1? I hope you have watched some of my videos shorts in where I have explained how to solve linear differential equation of order 1. So its solution is directly written as, the solution of this particular linear differential equation is directly written as y into integrating factor is equal to integration of integrating factor multiplied with this particular value, that is a value present on the right hand side. So let me that assumed as q into d of x. Okay, so this is basically the solution of the linear differential equation of order 1. All right. So how do we get to the integrating factor? The integrating factor for this particular linear differential equation is equal to e raised to the power minus of integration of 2 by x dx. That is basically the coefficient of y. Okay. The part that is multiplied with y is basically how is used in the integral to calculate the value of the integrating factor. So from here you get to the result as e to the power minus of 2 ln x, and this is from here you get to the integrating factor as 1 by x square. So from here you get to the integrating factor as 1 by x square. So if you apply this over here in this solution, we get to the value as x by y into 1 by x square is equal to integral of x into divided by x square dx. So this will become ln of x plus of c, some constant. This is y by x square is equal to ln of mod x plus c. But since we are dealing with x, because with the value of x belongs from 1 to infinity, that means x is always positive. So we don't need the value of the modulus over here. So we don't need the modulus over here. So we can write this general solution of this particular differential equation in this particular format. But since in the question it also mentioned about the value of the parameter, that is y, the value of y at x is equal to 1 is equal to 1 by 3. So we use this particular result, that is f of 1 is equal to 1 by 3. So if you use this result f of 1 is equal to 1 by 3, we get the result as 1 by 3 and x is 1, so it will be 1 only, is equal to ln of 1, and ln of 1 is equal to 0. So the constant from here I get is as 1 by 3. Okay, so the constant part I get from this particular value is 1 by 3. So from here, if we write that particular differential the solution of the differential equation is basically y by x square is equal to ln of x plus of 1 by 3. Okay, so from here you will get this particular differential equation, solution of the differential equation of this particular format. Okay, so if you have to find for the value of f when x is equal to e, so we have assumed that y is equal to a small f of x. So we have to put a value of x as e. So from there we will get to the value of y. So if we put the value of e, y is equal to e square into, so from here if you put e, this will be 1 and this will be 1 plus 1 by 3, that will be 4 by 3. So from here you get the answer as 4e square by 3. That is option number C. Okay, so the right answer to this question is option number C. I hope you were able to understand this particular solution. Okay, so let us move to the next question of this questions. Okay, so let us move to the second problem. Now, second problem is a problem which is a simple problem. This is the second question on probability. So the question says that the question reads as, consider an experiment of tossing a coin. Okay. Now, this particular experiment of tossing a coin is repeatedly done until the outcome of the two consecutive tosses are the same. That means whenever we get the two outcomes of the tosses are same, that is tail tail or head and head, then you basically stop that particular experiment. That's the experiment of tossing a coin. So it says in this particular problem that the probability of random toss resulting in a head is 1 by 3. That means this particular coin is not a fair coin, it is a biased coin. So then we have to find for the probability when the experiment will stop with head. We have to basically find the probability that this particular experiment will stop with the result, the last outcome as head. Okay. So how will we basically solve this particular question? So if we try to firstly assume, we know that basically the probability of the sample space is equal to 1. Okay, and since this particular sample space contains only two basically outcomes, that is head or tail, so these are basically the only outcomes of sample space, and these particular outcomes are mutually exclusive and exhaustive. Okay, that means basically this both of these will constitute the entire sample space. That means if I write the probability of getting a head on this random toss of a coin is 1 by 3, then the probability of getting a tail on the random toss of a coil will be 1 minus 1 by 3, that is equal to 2 by 3. Okay, I hope you have understood this particular the concept. Okay, because this tail and the head are the only two outcomes which basically constitute this entire sample space. Okay, and they are mutually exclusive. Okay, so from here if we have to find for this particular experiment will end with head. So when this particular experiment will end with head, so I'm talking of some possibilities. So let me try and simplify out some of the cases. Okay, now this particular experiment will end when we basically get head and head, okay, together, because we have to find for the result when this experiment will end with head. Okay, that means let me define that event ends E is the event when the toss ends with a head. Okay, so I write in a small format the toss ends in head. Okay, so this is the event we have to basically find that the toss of this coin ends in an head. So that the cases can be possible are that the two heads come simultaneously, or maybe tail comes, then head comes, then again tail comes, then again head and head comes, then also we stop this experiment. Or maybe there can be possibilities like a tail coming at first and then the head and then the head, then we stop the experiment. So I'm basically trying to write the all the possible cases when this particular tossing of a coin will end with a head. Okay, so if you try and some other possibilities, that is again you get a tail over here, then head, then again tail, then again head, then again tail, and then again head and head. Okay, so this is how you go on and continue up to infinity unless and until you get two heads and simultaneous throw. Okay, also there can be another case possible. There can be another case possible, that is you get head at first and then again tail and then head and head. Okay, so that's also another possibility of this particular experiment. Okay, when this particular experiment end with head. Also it can be like head, then you get tail, then you get head, then you get tail, and then you get head and head. So this is how you continue this particular experiment unless and until you end with two heads. Okay, unless and until you end with two heads on the consecutive throw. So this can be the two possibility. That is the first possibility when it starts with head, tail, or no tail, or when it starts with head and then tail and then head and head. Okay. So these are basically the two cases of this particular experiment. When this particular of this event, when this toss ends in a head. Okay. So if we try to find out the probability of this particular event, now this probability can be simply found out as, that is the first case, the probability of getting two heads on simultaneous throw is basically 1 by 3 multiplied by 1 by 3. Again, and so this is basically and over here, and for this commas, that is basically this case can be possible, this case may be possible. So we basically use the word or. That means we have to add this all the possibilities. So for this particular possibility, the tail, head and head, we'll write it as 2 by 3 into 1 by 3 into 1 by 3, plus for this particular case we will write the possibilities as 2 by 3 into 1 by 3 into 2 by 3 into 1 by 3 into 1 by 3. So this is how you continue up to infinity. Plus this case will also be possible. So for this particular case, we write the probability distribution as 1 by 3 into 2 by 3 into 1 by 3 into 1 by 3. Okay, plus, and this is how you continue up to infinity. And this is a way you continue and write for the other cases possible. Okay, so this is how you continue up to infinity, and you add up both these results to get to the required value of this probability. Okay, so you can write for this particular case. I hope you have understood this particular result. So the only thing that you basically have to simplify was the basically the formation of these two cases. Okay, so that was the only thing that you need to understand this particular question, and the rest things is basically a simple GP. So this is basically a simple geometric types of a geometric question. Okay, so let us move and solve this particular problem. Then we get to the probability of this particular event is basically equal to 1 by 9 plus 2 by 3 into 1 by 9 plus, that is basically 2 by 3 into 1 by 3 into 1 by 9, that will basically 2 by 3 ka whole square into 1 by 3. Okay, so this will be 2 by 3 ka whole square into 1 by 3 into 1 by 9. Okay, and so on up to infinity. So this is the first series, plus the second series will be like 1 by 3 into 2 by 3 into 1 by 9 plus 1 by 3 into 2 by 3 ka whole square into 1 by 3. So that means 1 by 3 ka whole square into 1 by 9. And this is the second GP. Okay, so if you solve this GPs, okay, so what we can see, this particular term doesn't count in the GP. What we see is this GP that basically has 2 by 3 into 1 by 9. 2 by 3 into 1 by 9 is basically the common ratio. Okay, so the common ratio, what we can see from this particular case. Okay, so if we solve this, there is 1 by 9 plus, for this particular GP, okay, for this particular GP, the first term is 2 by 27 divided by, we know the sum of the infinite GP, sum of infinite GP is a by 1 minus r, where the value of modulus value of r is less than or equal to less than 1. Okay, so this is basically the condition for the infinite GP which is converging. Okay, then only we have this particular formula, because otherwise if the GP doesn't converge, then won't be able to apply this particular result. Okay, 1 minus, and what is the common ratio? The common ratio will simply be, the common ratio if you see from here, the common ratio will get 2 by 9. Okay, so from here if you see the common ratio, you will get it as 2 by 9. Okay, you can check it on your own also. Okay, and for the second series, if you see for this particular series also, the first term is the 2 by, the first term is becomes 2 by, this is 81 divided by 1 minus, what is the common ratio? The common ratio, as you can see from here, the common ratio will be this, for this particular case also it will become, so from here you can see this will again become 2 by 9 only. Okay, so for both of this GP, this particular GP starts from here. Okay, this GP starts from here, and this GP from here is again having the common ratio as 2 by 9. Okay, so from here you basically get to the result as 1 by 9 plus 2 by 3 into 37 plus 2 by 7 into 9. Okay, so 3 into 7, sorry, not 37. That is, from here if you solve this, this is 2 by 21 plus 2 by 63. Okay, so if you solve this, if we try to solve this by taking the LCM and then approaching the result, so you get the result as, so you can solve it on your own. So the result will be 21 by, okay, so 2 by, sorry, 5 by 21. Okay, so that will be the simple result of this particular problem. Okay, so if you solve it on your own, you can definitely approach this by simple, by taking 2 and 7 common from here. This will be 1 by 3 plus 1 by 9. Okay, also you can take 1 by 3 common also, so this will be 1 plus 1 by 3, that is 4 by 3. Then it will become 4 by 3, so it will become 4 by 3 plus, this will be 1 by 9. So from here again, this is 1 by 9 if you take common. Okay, so if you take 1 by 9 common, and then you will get 1 plus, this is 8 by 7. Okay, so 1 plus 8 by 7, and if you take 7 on here, this is 15 by 7. So from here you will get 5 by 21. Okay, 15 by 7 into 9, so that will be 5 by 21. So from here you get the result of this particular probability question, that the experiment of this tossing a coil until two consecutive tosses of this having the same outcome will have the result. The result of this particular outcome or the event when this particular experiment stops with an head is basically 5 by 21. So this is the answer to this particular option, is basically option number B. I hope you are able to understand this particular problem. Okay, so it's a very pretty simple question. Only you have to basically think of the cases, that how you basically make the cases and correspondingly calculate the probability distribution regarding the particular cases. I hope this particular type of question was very important also for your JEE mains as well as JEE Advanced paper. Okay, you have simple question, but with little bit of understanding. Okay, like how to make cases and how to take the probability distribution. Okay, so this was okay, done. So let us move to the third problem. So the third problem is again a simple problem on the topic of ITF, inverse trigonometric function. Okay, again a very important chapter. Okay, so it's the question over here is mentioned as, for y which belongs to a real identity, then let cot inverse of x takes the principal values, that is 0 to pi, both are not included, there is open interval, and tan inverse of y takes the values from minus pi by 2 to pi by 2, both are not included. Then you have to basically find for the sum of all the solution of this particular ITF equation. Okay, so we have a ITF equation, that is tan inverse of some quantity plus cot inverse of quantity is equal to 2 pi by 3. Now the value of the y is given as that mod of y is less than or equal to 3, and obviously mod, so it is positive, so it is less than or equal, less than 3. Okay, so we have to find for all the values of y, and after all take the sum of all the values of y. Okay, so how will you approach this particular question? Now before talking on this particular question, you must have to understand all the properties about ITF. Okay, so let us move forward and solve. So for the first case, now when the value of mod of y is less than 3 and greater than 0, of course, so we have two cases corresponding to it. That is, y less than 3 is greater than 0, and another case will be when the value of y will be greater than minus 3 but less than 0. So that is the two possible condition or the cases that can be possible from this mod of y less than 3. Okay, these are simple properties, okay, of modulus function. So if we apply the properties of modulus function, we get two results. So let me solve for the first outcome, first results. Okay, that is when y belongs to 0 to 3. Okay, when y belongs from 0 to 3. So if y belongs from 0 to 3, what we see for the value, that is 9 minus y square by 6y, this will be a positive quantity. This will be a positive quantity, and we know that cot inverse of 1 by x is equal to tan inverse of x when x is a positive number, and okay, so if we apply this particular result, then we get to the value as 2 times of tan inverse, because what we see from this particular problem is that 9 minus y square by 6y is the inverse of 6y by 9 minus y square. So from here, if I apply this particular result, that is cot of inverse of 1 by x, we get to the tan inverse of x for x greater than 0. Okay, so from here, if I write this particular cot inverse as in form of tan inverse, then I will get the same result, that is tan inverse of 6y by 9 minus y square. So this will make up 2 times of tan inverse of 6y by 9 minus y square is equal to 2 pi by 3. Okay, so from here, if I cancel 2 and 2 on this right hand side, then I will get the result as tan inverse of 6y y 9 minus y square is equal to pi by 3. Okay, so from here you can apply tan on both the side, and from there you'll get to the result something as 6y by 9 minus y square is equal to tan of pi by 3. Now tan of pi by 3 is equal to root 3. So from here you can basically get to a quadratic equation involving a y. Okay, so from here you get to some quadratic equation involving y in this particular fashion as root 3 times of y square plus of 6y, okay, minus 9 root 3 is equal to 0. Okay, so this is a quadratic equation. Now the quadratic equation involving y. Now this particular quadratic equation involving y will have two corresponding values of y. So let me try and use the quadratic formula or the Siddhacharya formula. So from here I will get the result as minus of 6 plus minus root under. So if you solve this root under, that will be 9 root 3. So sorry, this will be 6 square, that 36 minus 4 times of 9 into root 3, that will become minus of minus, that will be plus, and 100 of 8. Okay, whole divided by 2 root 3. Okay, so from here basically get the result as equal to, so if I take the positive sign, okay, so if I take the positive sign, I'll get to the result as this will become 144, so this will 12, and 12 minus 6, so that will become, because why we are taking the positive sign, because the other value which will be negative will be rejected, because y is positive in the range of 0 to 3. Okay, because we are solving for the first case when y is belonging to this particular interval. Okay, so from here you will get to the result as 6 by 2 root 3, that will become 3 by root 3, that is simply equal to root 3, so the first answer will be equal to root 3, and we know the root 3 value is obviously less than 3. Okay, so the first value of this particular problem is root 3. Okay, and for the second case, when the value of y belongs to minus 3 to 0, then we can solve that tan inverse of, for this particular interval of y minus 3 to 0, what we see basically 6y by 9 minus y square is obviously negative, and we know that if this particular variate inside the cot inverse term is negative, that means inverse of that particular thing is negative, then we have to add the cot inverse from, if we want to convert it to tan inverse, we basically have to add it by a pi. Okay, by a factor of pi. That means tan inverse of 6y by 9 minus y square plus, for this particular cot inverse, we will write it as tan inverse of 6y by 9 minus y square, and this will be adding a factor of pi, and adding a factor of pi over here. So is equal to 2 pi by 3, because we have known the result, that is cot inverse of 1 by x is equal to pi plus tan inverse of x when x is a negative quantity. Okay, so this particular property, if we are applying in this particular scenario, then we get to the result as 2 times of tan inverse of 6y minus 9 minus y square is equal to, so if you take pi on this particular side, you will get the result as, so this will become minus of pi by 3, and if you take 2 over here, so if you cancel 2, this will become minus of pi by 6. Okay, so from here you get 6y minus 9 minus y square is equal to, so if you take tan on both the side, you will get minus of 1 by root 3. The tan of minus of pi by 6 is equal to minus of 1 by root 3. So from here you get the quadratic equation as, if you solve this particular, then you get the quadratic equation as 6 root 3 y square. Okay, sorry, I'm very sorry. So from here you get to the quadratic equation as this will be simply y square, and if you take this, and this will become minus of 6 root 3 y. Okay, minus of 6 root 3 y, and then we basically get the result as minus of 9. Okay, so from here minus of 9 is equal to 0. So this is the quadratic you get from here. Okay, now if you solve for this particular quadratic again, you get the result as plus of 6 root 3 plus minus root under, that is 6 root 3 ka whole square is nothing as 36 into 3, and 36 into 3 basically gives you 108. 108 and 4 into 30, that will again will become 144 divided by 2. Okay, so from here you get to the result as, so if you take the negative 1, okay, so if you take the negative 1, that is 6 root 3 minus 12 divided by 2. Okay, so if you divide by 2, you will 3 root 3 minus of 6. Okay, 3 root 3 minus of 6. So from here you get 3 root 3 minus of 6 is the only solution for when, because we take the negative sign, because y belongs from minus 3 to 0. We will take for the negative quantity. We will take for the negative quantity, not the positive. So we reject the positive sign. We take the negative sign. Okay, we take the negative sign over here. So from there we get to the result something like 3 root 3 minus 6. Okay, so this is the second solution. In the question we are asked to find the sum of all the solutions. The sum of all the solutions, on the first scenario I got the solution as root 3, and on the second I get the solution as 3 root 3 minus 6. So if I add this, I'll get 4 root 3 minus 6. Okay, so from here I will get 4 root 3 minus 6, which is option number C, and that is the right answer to this particular problem. So that is option number C, which is the solution to this particular problem. I hope this particular discussion is clear. Okay, so let us move to the next problem. Okay, I hope this particular solution is clear. So the next question and the last problem for this particular single type problem solution is this particular problem on vectors. Okay, so if we try to read out this question, that this problem is a simple problem. It says that the position vectors of the point P, Q, and R and S are given in fashion these particular coordinates. Okay, and fashion and these particular coordinates. Okay, respectively. Then you have to find and satisfy which of the following statement is or are true. So let us check for these particular conditions. Okay, now the very first problem, it says that the point P, Q, R, and S are not coplanar. So what do we mean by coplanarity? That means you basically need to form two, that is, if you have 4 points, okay, if we have 4 points like this way, okay, then we can make obviously three vectors for three respective vectors from this particular 4 points. And for coplanarity condition, if we can make three vectors, three corresponding vectors, then we can check for the coplanarity condition by simply taking out the scalar trivial product and equating to 0. If they are equal to 0, then they are coplanar, and in other cases, if they're not equal to 0, then they are not coplanar. So if we try to form the vectors, okay, so this is a very simply a lengthy problem. Okay, and this is nothing to do with the basically a good understanding, but just a lengthy problem. So if we try to find out all the vectors, so I'm writing the PQ vector. PQ vector will be simply become 2i cap plus 2i cap plus 4j cap plus 8k cap. Similarly, PR vector will become 12 by 5 I cap. Okay, PR vector, so yeah, the PR vector will become 12 plus 5, 12 divided by 5 I cap plus 6 by 5 j cap plus 12 k cap. Okay, and similar situation also PS vector. So okay, PS vector will become I cap minus j cap. PS vector will become I cap minus j cap plus of 6 times of k cap. Okay, so this is how we basically get to the three vectors. So if you respective assume this is P, this is Q, this is R, and this is S. So the coordinates like P vector is given as A vector, position vector of P is given as A vector, position vector of Q is given as B vector, position vector of R is given as C vector, and position vector of D is given as D vector. Okay, so this is how I calculate all the vectors, because for example, if I have to calculate for PS vector, it is simply calculated as D vector minus of A vector. So this is how you basically calculate a simple definition of the position vectors. Okay. All right, I hope this particular basics is clear in the concepts of vectors. Okay, so from here, if you try to take out the scalar product of this all the three vectors, that is PQ vector, PR vector, and PS vector, and scalar product will what will the value of the scalar product? So if I solve for the scalar product, that is basically solving the determinant. So if I solve the determinant, so what we can see, the 1 by 5 and 1 by 5 common over here. So if we try to take common from 1 by 5 from this PR vector, so let me take 1 by 5 common, and then we solve for the determinant value, and then we solve for the determinant value. Okay, so then we solve for the determinant value. It will become 2, 4, and 8. This will become 12, 6, and this will become 60. Okay, so that's you have to remember. This will 1 minus 1, and this will be 6. So if you solve this particular determinant, determinant will become, so if you solve for the determinant, what we can see in the second row, if I for example, if I wanted to make some transformation in the second row, okay, so if I take in the second row, if I take 6 common, this will become 2, this will become 2, this will become 1, and this will become 10. Okay, so if I take 6 common over here, okay, so this is 6 by 5 then. Okay, and then if a 2, it is becoming over here, this is 1 and minus 1. So what we can do, so we can make some transformation. Okay, we can make some simple transformation to make this particular result solve this particular determinant value. Okay, so what transformation we are basically I am looking for is basically subtracting two the second row from the first row and the third row from the first row. So if you do the transformation and we basically solve for this result, I have already solved out in my rough. Okay, so the result I get from the rough is basically this particular determinant is equal to 0. This particular determinant is equal to 0. That means these all three vectors, these vectors basically lies in a same plane. Okay, lie in a same plane. Okay, these vectors lies on the same plane. That means all these points are coplanar. So all points, that is P, Q, R and S, are coplanar points. Okay, are coplanar because all three vectors are coplanar. STP is equal to 0. So they are basically coplanar points. So the question says that, well, the option says that the points P, Q, R are not coplanar. So this is basically a false option. Okay, so let us look for the second the option. It says that B vector plus 2 times of D vector by 3 is a position vector of the point which divide PR internally in the ratio 5:4. So if you see over here, if you talk of PR, okay. So if you talk of PR, so PR is this particular line. Okay, so if you talk of PR and it says that B vector, so PR has a position vector of A and this is C. Okay, so if I have to divide a point which internally in the ratio of 5:4, I get to that unknown point. That unknown point will be 5 times of C vector plus 4 times of A vector divided by 9. Okay, and that particular point is that particular point similar? Okay, is that particular point similar? This is similar to B vector plus 2 times of D vector divided by 3. Okay, is that similar to this particular point? So let us check for it. Okay, now how will we basically check for that? Okay, how will we basically check for that? So what we can do, okay, so if we substitute the values, that is 5 times of C vector, 5 times of C vector is basically 17 I cap plus 16 J cap plus 35 K cap plus 4 times of plus this will become 17 I cap, okay, 17 I cap plus 16 J cap plus 35 K cap plus 4 times of A vector and 4 times of A vector 4 plus 8 minus 20, 4 I cap plus 8 J cap minus 20 K cap and whole divided by 9. So from here, if you solve this, you will get the results as, okay, so this will 21 by 9, okay, 21 I cap, and for j cap it will become 24 j cap, okay, and for k cap it will become plus of 15 k cap whole divided by 9. Okay, so this is basically the point which internally divides the line PER in the ratio of 5:4, and for this b vector plus 2 times of d vector by 3, the result for this particular will be 3, 6 and 3, 3 I cap plus 6 j cap plus 3 k cap plus 2 times of d. So 2 times of d is 4, 2 and 2 and 2. Okay, so 4 I cap plus 2 j cap plus 2 k cap whole divided by 3. This will simply become 5 I cap. Okay, sorry, not 5. This is 7 I cap. 7 I cap plus this will become 8 j cap plus 5 k cap whole divided by 3. So this is similar. So if I cancel out with some 3 over here, this will be 7 by 3 I cap, this will be 8 by 3 j cap, and this will be 5 by 3 k cap. So this is very similar. These values are equal. That means the vector b vector plus 2 vector divided by 3 is the internal bisector of this PQ line in the ratio 5:4. So that's how we get to the right answer. This option B is therefore correct. Okay, therefore option B is correct. Similarly, if we talk for external division, and if you check this on your own, you will find that doesn't satisfy. Again, option C is again a bogus option. Okay, so this is also incorrect. So if you check for the last condition, that is basically you have to find the cross product of B cross D, and you have to find the square of the magnitude of the vector. So you know how to basically deal with cross product. So if you try it on your own, you can try it like this fashion. That is B cross D vector cross product, and if you take the modulus of the whole square, that is simply have to find the firstly you find the cross product magnitude, and then you basically get to the magnitude and then square it. Okay, so this will be simply as, so B we know that 17 by 5, then 16 by 5, then we have 7, and we know D vector as 2, 1 and 1 over here. Okay, so if you take this particular vector, if you solve this particular result, you'll get this results as 3 I cap 3 I cap plus 3j. I have done it on my rough solution. Okay, you can do it on your rough on your own. Minus of 9k cap and इसका जो मॉडुलस उसका होल स्क्वायर लेना है. Okay, so we have to find for the modulus of this particular vector and then take the whole square. That is similarly simple as 9 plus 9 plus 81. So this will become 99. Okay, this will become 99. But in the option it says that it is equal to 95. So that is again a wrong option. So only option which is correct in this particular problem is option number B. I hope the right answer to this question is option number B is clear. Okay. So with this I have completed the section 1 of paper 2. Okay. But with this particular video solution, I'm also taking up the section 3, that is basically the numerical type problem. Okay, so I will be taking only 3 problems of this numerical type section. Okay, so to end this particular video solution. Okay, so let us move to the next first problem, and this particular problem is from the section 3 of JEE 2023 paper 2. Okay, so I'm going to take this is the numerical type of section 3. So this is section 3, and the previous all the 4 questions were from section 1, that is a single correct questions, and the remaining problems of section 3 will be taken up in the upcoming part of this particular video solution. I hope this things is clear. So if you haven't subscribed to my channel, then definitely subscribe to it. Okay, so with this, if we start, so this question reads as that for x belonging to a real identity, the tan inverse of x again takes the real that principal values, that is minus pi by 2 to pi by 2. Both are not included, and then you have to find the minimum value of for the function which is defined by this result, that is f of x is equal to this particular result. Okay, so if we try and solve out this particular question, that is this is again a question where we have to apply the Newton-Leibniz rule. Okay, or Newton-Leibniz theorem, what we say. Now the function f of x is given as integral 0 to x tan inverse of x. Okay, that is defined as e raised to the power t minus cos of t whole divided with 1 plus t raised to the power 2023 dt. Okay, so if you have to solve for the minimum value, that we basically have to apply the concept of maximum minima, and we have understood, we have studied for the concept of maximum minima. For getting the value of the extrema, we have to basically get to the result of f dash of x and then equate it to 0. From there we basically get to the points of extremum or the critical points. Okay, or the critical point, and we have studied that maximum or minimum value always occur along the points of critical point or along the critical points. Okay, so from here if you differentiate this particular function by simply using the Newton-Leibniz rule, okay, that we have already used in the first problem of the today's video. Okay, so the Newton-Leibniz rule. So from here you will get to the result as e raised to the power x tan inverse of x minus cos of x tan inverse of x whole divided by 1 plus x into tan inverse of x. Okay, raised to the power 2023 multiplied with, and then we will differentiate this particular quantity. So if we differentiate by using the product rule, it will be tan inverse of x plus x by 1 plus x square. Okay, so and if we equate this particular quantity, that is f dash of x is equal to 0, so from here we get to the values of x as the critical point. So we are solving for the critical points. So we are solving for critical points. Okay, so we are solving for critical points, that is basically the value of f dash of x is equal to 0. So for the critical points, okay, what we can see now, we know that e raised to the power x is always positive. That means e raised to the power anything is always a positive number. So from here this particular quantity can never become 0. Okay, because this particular quantity will be asymptotic to 0 at minus infinity when this particular whole quantity goes to minus infinity, but that is asymptotic value. We are not getting the perfect value of that, so we can neglect these terms. We can only talk of these particular terms. Then we get to the result as x square plus 1 into tan inverse of x plus x is equal to 0. So this is a result for the equality to have the condition, that is f dash of x is equal to 0. So from here we get to the results, that is x square plus 1 is again a positive quantity, so that means this cannot be 0. So the only thing that is possible in this particular scenario is that when the value of x is equal to 0. So that's how you basically get to the result as 0, because tan inverse of x again takes the value from minus pi by 2 to pi by 2. So if we substitute tan inverse value, that is at x is equal to 0, we get to the tan inverse of x is equal to 0. So from here you basically get to the value of this particular equation holds true only and only when x is equal to 0. Okay, now you can also solve this particular by simply use of by drawing the graphs. Okay, so how we basically do this by simply taking the tan inverse of graph. So if you know graph of tan inverse of x, that is basically asymptotic at minus pi by 2 and pi by 2, and then plotting the graph of x by 1 by x square, okay, and then taking the negative of that by simply doing some graphical transformation. So from there you will also see that both the graphs will basically intersect on only point x is equal to 0, okay. I will intersect on point x is equal to 0. So the minimum value of this particular function will occur along at x is equal to 0. And what is the minimum value of this particular function? That will be, we see, if we put f of x is equal to 0, then we get to the minimum value of this particular function, that f of x is equal to 0, that means this 0 to 0, and we know whenever the integral limits of the integral are basically similar, then we get to the value of the integration is equal to 0. So this will be big 0, okay. So the result of this particular numerical type problem will be equal to 0. So the answer to this particular numerical type question is equal to 0. I hope this particular solution was clear. It's very simple problem, okay, very simple problem. Just you have to only understand your understanding of graph. So unless you are able to do this particular graphical transformation, you are basically able to get to the solution. So if you are someone who is not able to do this particular graphical transformation, stay tuned on this particular channel, because I will be starting up a topic on play with graph, dedicated towards like drawing graphs, okay, like how to draw the graphs, how to take the maxima minima, how to draw asymptotes, okay, and things regarding that, okay. So for this particular problem, let me help you with the graph, that is y is equal to x by 1 plus x square. Now how we basically get to this graph? Now what we try to firstly find the graph value, that is at various points we have to find the value of the graph, that is at x is equal to 0 and x is equal to infinity and x is equal to minus infinity. So at x is equal to 0, we see that y is equal to 0, and at x is equal to infinity, we get the value of y also tending towards infinity. Similarly, at y is equal to, these are wrong value, okay, at x tending to infinity, okay. So at x tending to infinity, we have to basically take the limit, okay. So x tending to infinity, the limit will be something like x plus 1 by x square. So what we see, that 1 plus x square is a bigger quantity rather than x, okay. So that means will approach toward infinity at greater value than this particular value. Then this particular result will be small infinity by big infinity, that will become 0. So what we can also see by the result, that is if we take the higher power, that is from here, if we take x common, then we get 1 by, so the limit is already there. So limit extend to infinity. That is, if I take x common from here, that will be 1 by x plus. Okay, and for the from the denominator part, sorry. So from the denominator, we are taking x square common, and from the numerator, we are taking x common. So that will become 1 by x whole multiplied with 1 by, and from the denominator one, we take 1 by x square common. This is plus 1. So from here, what we see, that 1 by x is left out in this particular limiting value. That means this will make the limiting value as equal to as equal to as equal to 0. Okay, so that the limit will tending to 0 at plus infinity as well as minus infinity. Okay, so that's how we basically get to the idea that how the graph of x by a 1 plus x square will look like. And if we take negative of that, then the entire graph will shift from the positive y-axis to negative y-axis. That means that x is equal to 0, the value is 0, and also at infinity it will again approach 0. Okay, and similarly minus infinity is also approach 0. Okay, now we have to check for the nature of the region, that is what will be the nature at this particular intermediate values. Okay, so for that, if we try to differentiate this x by 1 by x square, we get the result as 1 by x square ka whole square multiplied with, by simply using the quotient rule of differentiation, okay, by simply with the quotient rule of differentiation. So we are trying to differentiate this y dash, okay, this is y dash of x is equal to, so into 1 minus of x into 2x. So from here we get the result as minus of x square plus of 1, okay. So from here get minus of x square plus of 1, and this is again a positive quantity. Okay, so what you see from this particular result, that is 1 minus x square, and 1 minus x square can be factorized as a 1 minus x and 1 plus x. That will basically give you two basically critical values, that is minus 1 and plus of 1, okay, plus of 1. So if we see for the values, okay, at how the graph behaves at plus 1 and minus 1 by simply using the concept of maxima minima. So we plot it on the number line. Okay, if we plot it on the number line, that is minus 1 and this will plus of 1. Okay, so what we see, because this is not x is over here, so we have to have a format of x minus 1. So for having x minus 1 format, we can take negative common, and for that this will make the sign rule, that is basically negative over here. Okay, I hope you know this particular sign rule in basics of mathematics. Okay, so from here this will become negative, and then there will be positive and then negative. Okay, I hope you know this sign scheme. Okay, So from this sign scheme, what we see that in the region minus infinity to minus 1, this particular graph, the value of y, that dy by dx is simply negative. That means it is decreasing function. And since we are dealing with negative times of, but in this particular problem, we have to draw the graph for minus of x by 1 plus x square. That means if in this region minus infinity to minus 1, the graph is decreasing, for negative 1, it will be increasing. Okay, so that will become like minus 1 from here. If you put the value of minus 1 in this particular result, we'll get the values there. We'll get the value. Okay, so if we put the value of minus 1 for this particular result, we'll get the value as 1 by 2. Okay, so we will get the value as 1 by 2 from here. Okay, so this will be increasing type of graph. So at 1 by 2, it will become actually 1 by 2. And then, okay, so this will be a smooth graph only. So it will take a turn again. Okay, so this graphical analysis can be simply done by methods of, by simply using like how the concavity will occur. So that can also be done by taking the double derivative. So I'm not going to do so much of detail. You can plot it on your own. Okay, so n will become 0, and at plus of 1, it will become minus of half. So this function will look like something like this. Okay, and then it will approach half, minus of half here, and then it will become asymptotic at 0. Okay, so from here you get to the nature of the graph something like this. Okay, this will again become minus of half. Okay, so and for the tan inverse of x, and we know minus of half is basically as 0.5, and pi by 2, and pi by 2 is value is 1.57. So this is pi by 2. So this will be the tan asymptotic value, and this will again look like similar to this. Okay, similar to this. Okay, so they both the graphs basically intersect only at one point, that is x is equal to 1, and that particular point is a critical point. That particular point also corresponds to the point of minima. Okay, point of minima. So that's how we basically get to the solution of this particular problem. I hope this particular result is clear. Okay, so with this, let us move to the third problem, and this is again a problem on differential equation or simple linear differential equation. Okay, linear differential equation. So you can see and assume that how important is to study the linear differential equation. You almost have a question on linear differential equation, not one, but at least 3 problems on JEE Advanced 2023 paper on linear differential equation. So this is a very hot topic for your JEE Advanced portion as well as the JEE Mains portion. Okay, I hope you must be covering that particular problems in understanding, good understanding. Okay. All right, so let's solve this particular problem. So this particular problem has a differential equation. So if I solve this particular differential equation and make it in the format of simple format, that is dy by dx minus of, I simply divide by x square minus 5. Okay, so from this I will get the result something like this, minus of 2x divided by, not divided, it will be only multiplied because square over here. Okay, because x square minus 5 ka whole square is present, so this will become x square minus 5 only multiplied with. Okay, so from here if we get to the linear integrating factor as e raised to the power minus of 2x divided by x square minus 5, so from here and dx, so if how to solve this particular integration is simply by substitution. Okay, if we assume x square minus 5 is equal to t, then we get 2x dx is equal to dt. So if we substitute back, that is minus of dt by t. So this will become e raised to the power minus of ln t. That will become 1 upon t, and 1 upon t. If we substitute again back, then we'll get 1 upon x square minus 5. So that's the integrating factor. So we know the solution of our linear differential equation is y into integrating factor is equal to integration of the right hand part into integrating factor. So this will become y into, so y into integrating factor, that is 1 by x square minus 5 is equal to integration of 1 by x square minus 5 whole multiplied with minus of 2x into x square minus 5 into dx. So x square minus 5 and x square minus 5 get cancelled, and we get simply that integration as x square and plus c. Okay, so that's the value of this particular the integral solution of the linear differential equation. And for getting the value of c, we have already been provided with the data, that is y at x is equal to 2 is equal to 7. So if you solve this, so this is y is equal to minus of x square into x square minus 5 plus c. If we put the value of y as 7 at x is equal to 2, then we'll get 4 into 4 minus 5 plus of c. So this will become minus of 1, and minus of minus will become plus of 4. So from here I get the value of c as 3. So for this solution, we get y is equal to x raised to the power 4 minus of x raised to the power 4 and plus of 5 into x square plus of 3. So the solution of the differential equation, which is simply a polynomial equation. So for solving this, or for getting the minimum and maximum value, what we basically do, we take negative common. This will become x to the power 4 plus 5x square. Okay, so sorry, minus 5x square. This will become minus 5x square. Okay, minus 5x square minus 3. Okay, so from here, if I try to simplify by using by using the proper clubbing the quadratic part, or by making it square and then the left out quantity, then that particular square value we can compare it. Okay, so we can simply use the results. Okay, I haven't done any mistake, I believe. Okay, so from here, okay, so from here you will get to the results. So from here, if you see this particular, by clubbing or making it square, it will become something like minus times of, and if you take x square minus 5 by 2 ka whole square, then you basically add plus of 25 by 4, and if we add plus of 25 by 4, then our responsibility is to also subtract 25 by 4. Okay, so if you subtract 25 by 4, and then it will become negative times of x square minus 5 by 2 इसका whole square minus of this will simply become 12 plus 25, this will become 37 by 4. So if we check for the values, then it will become 37 by 4 minus of x square minus 5 by 2 ka whole square. So the value of this equation, or the solution of the linear differential equation, is something as 37 minus some square value, and we know the square value is always positive. So if we are subtracting some quantity, some positive quantity from the 37 by 4, so that will make the maximum value of this particular y as the maximum value of this y as 37 by 4. Okay, I believe I haven't done any mistake. So in case I have done any mistake, please mention out in this comment section. Okay, comment section. Okay, I will get back to you. Okay, so I hope this particular thing was clear. Okay, if I haven't done any mistake, then the result will be 37 by 4. Okay, okay, with this, let us move to the last problem of this today's discussion. Okay, so this problem is again a very good problem, that I will say again a problem of probability or conditional probability. So this is a very important types of problem, that is, we have to basically, the problem reads as, let x be the set of all 5-digit numbers using the digits 1, 2, 2 and 3 times of 2, and 4, 2 times of 4 and 0. For example, 22240 is in x, whereas 02244 is not in x, because it is not a 5-digit number. Okay, and similarly 444 and 22 are not in x also. Okay, so this 444 and 22 are also not in x. Okay, so that is talking about that whenever the number is basically having 0 at the last digit. Okay, it has the number 0, and if it has a number 0 in the first, then also not a 5-digit number, so that is also not in x. But the number 444 and 22 is also not in the set of 5-digit number. Okay, suppose that each element of x has equal chance of being chosen, then p be the probability, conditional probability, then p be the conditional probability that an element chosen at random is basically a multiple of 20, given that is also already a multiple of 5. Okay, so that's a very interesting problem. Okay, so if we try to solve out, we have the digits as 1, 0, 1, that is 3 times of 2 and 2 times of 4. So we have 7 digits over here. So if we talk about the number divisible by 5, so let me take that event as a event. So if I talk about a number which is divisible by 5, so how to make that numbers which is divisible by 5? So we know that the numbers which are divisible by 5 will obviously have the last digit as 5 or 0. Okay, will obviously have the last digit as 5 or 0. So if we are talking of possibilities which have the number as 0 in the end case, because only the digit allowed is 0, so we have the 0 in the last digit, and remaining 4 places have to be filled with these particular combinations of number. So how these numbers are chosen, that is basically another very important trick, that there will be many cases. Okay, and since we are not allowed, like there will be many cases, like first case may be corresponding when 2 fours are chosen, okay, or when two twos are chosen, okay, or when three twos are chosen, and then only the possibilities are there. So that's how basically deal with this particular problem. So this particular problem can also be dealt by the simply use of by multinomial theorem. Okay, multinomial theorem. So if you have studied the multinomial theorem, then you will be able to understand this particular problem, like how to approach this particular case of this number situation. Okay, now this multinomial theorem is basically is dealt about by whenever you basically solve problems on equations. Okay, so let me take a moment to make you revise the how where we basically apply the concept of multinomial theorem. For example, we have an equation like x1 plus x2 plus x3 is equal to 5. Okay, and we are given with a set of values of x1 and x2 and x3. Then how many possible values will be there corresponding to this particular each of these three variables? So then in this particular scenario, we basically make use of the case of multinomial theorem. That is basically trying to take out the coefficient of this particular x raised to the power some value in a particular expression. So that's basically the multinomial theorem. So if you remember from the multinomial theorem, we can also write these particular numbers which are basically divisible by the numbers which are divisible by 5, that is basically the event A. So for that particular event A, I can do this particular all the numbers as I can write it as coefficient of x raised to the power 4, because we have to take for all the 4-digit numbers. Okay, we have to choose the 4-digit numbers. So the remaining 4 digit, because the last digit is obviously chosen as 0, because for the number divisible by 5, the last digit must be 0. So for the remaining digits, I have to choose in this fashion. This will be for these 4 places. I can choose a coefficient of x to the power 4 in the expression in expression 4 factorial into 1 plus x raised to the power 1, because 1 is present only one times. Okay, plus this will be multiplied, okay, multiplied with 2 is present 3 times, so that will become 1 plus x square plus x cube, okay, x square by 2 factorial and x cube by 3 factorial, whole multiplied with, and 4 is present 2 times, that will become 1 plus x square by 2 factorial. Okay, so that's how you basically get to the result. And if you directly calculate it, you will get to the value as 38. I have calculated on my own, so you can see it. You will get to the value as 38. So it's simply taking out the coefficient of x to the power 4. Okay, and don't forget to multiply by 4 factorial. Okay, so this particular problem can be done in multinomial theorem, but also this particular problem can be done by taking out different cases. So that can also be done. Okay, so that will be basically a bigger of a situation that you can do on your own. Okay, like taking cases, like you can make one cases when all the two fours are chosen, and the remaining digits are 0 and 1. Okay, so sorry, 0 is already chosen, so we don't have 0 case, and the remaining digit is basically, and then we have only two cases, that is 1 or 2. Okay, so then we have to basically add in this particular number, that is basically 4 factorial divided by 2 factorial. And another case may be when we basically twos are chosen. Okay, when both the twos are chosen, and the remaining cases I am left out with basically choosing a 2, 4 or 1. Okay, then we have three possibilities. Okay, so from the three possibilities we choose two cases, and then we basically add this number as 2 factorial 4 factorial divided by, if the three twos are chosen, then 3 factorial. And there can be another case when, so then this particular quantity will not be encountered, that is basically taking the case when 3 2 just chosen, so there will become this particular case is 4 factorial by 3 factorial. And then there can be another case when out of these two quantities we basically choose, out of these two quantities we basically choose only one quantity, 2c1 into 4 factorial by 2 factorial. And these are the cases. Okay, so if you evaluate these particular values also, you will also get the value as 38. Okay, I hope you can do it on your own, and you can check the result whether the 38 is coming or not. So this is simply the solution which we basically approach by multinomial theorem. I hope you have understood this particular problem. And for the numbers, okay, and for the number of numbers which are divisible by 20, numbers, okay, which are divisible by 20, so that the numbers which are basically divisible by 20 will be divisible by 4 and 5 together. So the numbers which are divisible by 5 will have a 0 at the last digit, and the numbers which are divisible by 4 will have the last two digit will be divisible by 4. Okay, we have studied that how to check for the divisibility of 2 raised to the power p, that is the last p digits will be divisible by 2 raised to the power p. Okay, so for divisibility by 4, the last two digit must be divisible by 4. That means we have only cases as this last two digit can be 20 the last digit can 20 or the last digit can be 40. So corresponding two cases, we will basically have the results. Okay, we basically have the results. So if we have 20 as the last digit, rather the remaining three digits can be chosen accordingly. Okay, so you can make cases, and the remaining numbers are basically 2, 2, 4, 4, and 1 are only left over here. Okay, so that regarding the three cases, we can again make the cases by simply the like how we basically make cases. Okay, so that you can do on your by yourself also. Okay, like the similar case we did over here, like I showed you like how to make cases, and if you similarly make these cases for this particular two cases also, we'll get total of 31 ways. Okay, that will be 31 ways when these particular numbers will be basically 5-digit numbers will be basically divisible by 20, and that particular event I'm letting it as B event, and we have to find the condition probability of B given that A has already occurred. That is a number which is divisible by 20 given that number is already divisible by 5. So this particular condition probability is written as, that is B U intersecting A divided by probability of A. Okay, so from here I will get the result as 31 divided by total number of cases, so I am representing total number of cases T divided by, and 38 divided by total number of cases is T, so that the total will be 31 by, the result will be 31 by 38. So from here you get to the probability value P as 31 by 38. So we have to find for the value of 38 times of P. We have to find for the value of 38 times of P. So if we have to find for the 38 times of P, the value will be simply 31. So the answer to this particular problem is equal to 31. I hope this particular numerical type question was clear. Okay, now this is basically a simple problem that you can see. No, not very simple, but you can think of like how to make cases and then definitely approach this particular problem. I hope this particular problem is clear. Okay, so with this I come to the end of this today's discussion. So that was all. That was all, a lot of question. Okay, and the next part I will continue with the remaining problems of the numerical type, and then we'll move to the paragraph type and the multiple type of question that was asked in the paper 2 of JEE Advanced 2022 paper. 23 paper, sorry. Okay, so with this I come to the end, and I hope you have understood all these particular problems. And if you have understood all these particular problems, and if you have liked this particular video solution and you like my effort, then definitely like this particular video and also subscribe to my channel to never miss out any upcoming content. Also press the notification button. Okay, so with this I take a leave from today's video discussion, and thank you.